All right, let's get started. Thank you for being here this evening. Welcome to the Science on the Sound here at the Coastal Studies Institute. My name is Reed Corbett. I'm the executive director here, and we are very excited to welcome David Glenn and Ryan Ellis from the National Weather Service located, for this office, located in the Newport, Morehead City area. I want to start with giving you a few sort of announcements, other things that are coming up, and then I'll introduce them a bit more formally and let them get started. And so, as many of you know, we do offer a lot of different programs. The next Science on the Sound is about a month from today. It's November 21st, not to overshadow, but to go ahead and make you aware, is we will have from the National Park Service, George Hermio, who is the historical architect for the National Park Service Hatteras Division. We don't have a title for his talk yet, but he has been working a lot for the last several years on developing a plan from a historical architectural perspective, and we'll give updates on that, on some of his work. We have several upcoming education programs. If you are interested in a tour of CSI, we are doing those on the 2nd and 4th Wednesdays of the month. So the next one would be November 13th. And so I guess we've already done our two for this month. I'm not sure what the date is right now. So anyway, so November 13th, 27th, if you're interested in a guided tour of CSI to learn more about the research and other programming that we have going on here at CSI. And so we do have some family programs exploring oyster ecology on November 6th and November 25th. Those are from 3:30 to 5 p.m. And for those of you that have kids or maybe grandkids, we have these 7 and 9-year-old mini camps. It's called Seaside Science Scouts. These are during when there are teacher work days for Dare County schools. And so the next one is November 11th. Again, it's 9 to 3:30. So it's when the kids are out of school. These are for 7 to 9-year-olds, and we have them all day. So lots of things going on. We actually just put out our summer newsletter, I think, last week. If you are on our email list, you should have received that. If you want to get on our email list, we're happy to welcome you on to that. Again, our newsletters sort of produced here through our outreach engagement group. It's a great way of learning a little bit more about what we're doing, as well as seeing some of the great imagery and sort of the work that's being done. All right, so with that, I'd like again welcome David and Ryan. I'll give you a little bit of background of each of them. David Glenn is currently the meteorologist in charge for the Newport Morehead City office since 2018. David started with the National Weather Service in 2008 in Portland, Maine, and has been with the current office since 2010. David has led the operation since that time through, as many of you might be aware, through several impactful years of hurricanes, nor'easters, and other storm events. What I like about this, and David and I have talked for several years about trying to get him up here for an event like this, is really that opportunity for science communication, something that he's also very passionate about. Ryan Ellis is the Science and Operations Officer at the National Weather Service office, the Newport Morehead City office since 2019. Ryan's been a meteorologist for 10 years with the National Weather Service, first in Raleigh and then I guess spent some time in Honolulu.
Yeah, I did grad school there. And
all right.
Yep.
And now, again, at the Newport Morehead City office. What I learned today, which I didn't know, is Ryan is also an adjunct professor at East Carolina University, working with their meteorological program, their atmospheric science program. So with that, I'll hand it over to you. Again, thank you for being here.
All right, thank you. John, can you hear me okay, sir? All right, so I didn't want to forget this, so I have a brochure here to remind me. Before you guys leave there, we do have a small stand with some handouts, whether it's on hurricanes, rip currents, flooding, heat, just general weather hazards. Make sure you see this before you leave today, okay? Thank you guys all for being here. We really appreciate you coming out. Like you said, my name is David Glenn. I'm the MIC, or meteorologist in charge at the Weather Service office in Newport, Morehead City. So where is the Weather Service? First, we're going to tell you a little about who we are and what we do. And then Ryan is going to come in and tell you about how we're going to do things a little differently. And that can be in the short term, as in next year and the year after that. We're using more probability in how we communicate what we forecast. So we're going to start with the basics, show you guys all that, and then we'll get going. So where is the National Weather Service, or NWS? We're under NOAA, one of the 6 line offices under NOAA, which is under the Department of Commerce. In the map there, you can see all the little chicle maps of where each office is located. Some of them are quite a bit bigger than others. I'll give you an example here. FFC, that's the Atlanta. They have over 100 counties they're responsible for. Bless their hearts, because that's crazy to me. That's a lot of responsibility that they're in charge of. But every office that you see here, there's over 100. I think we were trying to figure out earlier, I think it's 122. Every office is staffed 24/7, 365, whether it's a nice, beautiful day like it was today or it's Hurricane Florence on your doorstep. We're always there. There's always somebody there, multiple people there. And I'll tell you a little bit more about staff here in a minute. And we do a lot of community outreach, because it's not just us producing the forecast. We also need to make sure you guys are all educated to know what we do when we say, oh, you got a tornado warning on your phone, or flash flood warning on your phone, or Dare County says you need to evacuate. What do, right? So we're helping communicate that in the community. And just lastly here, before I go on, the mission. It's quite a bit longer than this, but in generic terms, it's the protection of life and property and the enhancement of the nation's economy. So our office, our area of responsibility, it's only 14 counties. Remember, I told you Atlanta was 100. We're lucky we only have 14 counties, but we have a large area of responsibility on the marine side. So what you see there in yellow are the land areas and the marine responsibility, Pamlico, Albemarle Sound, all the little nooks and crannies there, out to 20 nautical miles. So we provide the forecast and we provide warnings for that. From 20 to 40 nautical miles, we provide marine warnings for those areas. Other parts of the state are covered by Wilmington, Raleigh, Wakefield, Virginia, similar to the map we showed previously. So what's it like in our work environment? So Reed mentioned some high impact storms, right? We've had some pretty big ones here in eastern North Carolina. This was an image of the ops floor. There's 9 people in that. This is the image of the ops floor leading up to Hurricane Florence. In fact, if you see the little red bullseye on the left, that's the wind field that we had, just happened to be up on one of the screens. We're doing a briefing in this scenario here. It's 24 hours a day, 7 days a week, plus overtime for significant weathers. They're on average 2 to 3 people per shift, unless it's a massive hurricane, and we surge staff and we make sure everybody's there to help. We usually have a midnight shift, a day shift, and an evening shift. Ryan and myself and one other meteorologist manager, Mr. Eric Hayden, are the management team for the meteorologist. We also do work shift, and that's why Eric's not here tonight. Eric's a great speaker, much better than me. I wish he was here, but Eric couldn't make it because he's working midnight shifts tonight. He's covering shift tonight, so that's the way it works sometimes. But when we're fully staffed, it's in total of 20, 21 people. Right now we're down 3. We're down 1 meteorologist and 2 electronics experts. But we're doing fine, we're doing well. All right, so let's get into the forecast. What's a 7-day forecast? Sky cover, maximum minimum temperature, wind speed, wind direction, the chance of rain, the type of rain, the amount of rain, all that is included in the daily forecast. So as you can see at the top there, weather.gov/Morehead City, it's an easy way to do it. One of Eric's favorite sayings is, if it's weather you love, it's weather.gov. I know it's hokey, but it really sticks. I've never forgotten, ever since, I don't know if he made it up or where he got it from, but it really sticks. Yeah. If it's weather.gov, if it's the weather you love, it's weather.gov. So that's an example. Oh, let me go back one more. We also have the forecast in a graphical form. You can view it in map like this. It also works for the ocean parameters, what's going on with winds and wave height offshore. We also do aviation forecasts. Everybody's probably been in a plane, whether you realize or not, before you land or before you take off, the pilot has to look at what's the current conditions, where you are, where you're taking off, and where you're landing to determine how much fuel you should have. Because you don't want to have too much fuel, then you burn too much because you weigh too much, right? And you don't want to have too little because you're going to have to land somewhere else. So planning of the weather conditions highly impacts aviation. This is an example, the top here. Do we have any pilots in the audience by any chance? No, that's okay. All right, so the top there looks like gibberish. That's okay, I'm not gonna describe that to you. But the bottom image here is cloud ceiling height. And you can see the values, 800, 600, 1200, and then up here on the Outer Banks, 5,000 or 5,800. This would be a great example of like radiation low stratus that can develop. And in this situation, that can alter who can fly into these airports. So the point locations we forecast for are Greenville, Kinston, Jacksonville, and New Bern, but we create graphical forecasts so anybody could use this. So for example, if there was a live flight between Greenville and Manio Airport, they're gonna look at this information to help determine what the conditions are, where they take off and where they land. So that's an example of what we do for aviation. Here's what we have for our marine forecast. So the bays, sounds, nearshore coastal waters out at 20 nautical miles, that's our area responsibility. When you go 20 nautical miles and beyond, that's the Ocean Prediction Center. And when you go even farther than that, that's the high seas forecast. That's also the Ocean Prediction Center. And depending on your latitude, can be controlled by the Hurricane Center, which is actually, it's called the Tropical Analysis and Forecast Branch down in Miami. Before we move on to talking about outreach, I wanted to talk a little bit about another piece that's really important here along the Outer Banks, and that's rip current forecast, right? I showed you the brochure from rip currents. We're always talking about rip currents. It's one of the deadliest phenomenon that impacts our area. A lot of times it's not us. It's the people that come in, our visitors that are visiting from the Midwest or someplace where they treat it like a lake and they're not sure what to expect on the coast. So we really emphasize a lot on rip current forecasting. What does it mean for Eastern North Carolina? Why you should be aware. This is an example from, let's see, last month, the middle of September. I believe there was a hurricane farther offshore and it was sending a lot of swell energy coming in, impacting our area. So in this case, what you see here are the probabilities produced by NWPS, or the Nearshore Wave Prediction Scheme. This is a big part of how we create our forecast. We actually update it 3 times a day, once in the middle of the night, once in the afternoon, and once in the morning.
So yellow's not bad?
Yellow is moderate, red is high, and below 25% there is low. So how does that translate to our forecast? This is what we had out for that day. It's very sophisticated though. I want you to pick out like this yellow part here. Why do you think why don't we just go red across the board? Say it again. The direction. Okay, that's right. You see the little yellow there? It's protected, right? Everybody knows Cape Hatteras, right? This is Cape Lookout. And that shoal comes down here and it's actually protecting a part of this called Shackleford Banks and the southern areas here. So because of that, we were aware of it. We didn't just blanketly say everything's a high threat of rip currents. We knew this area wasn't as high because it was a little protected. So some of the examples of the science that we use in creating the forecast. All right, so we talked about how we create the forecast, the different parts of the forecast we create, but we also get out in the community just like we're doing tonight. We want to educate folks to take our information, whether it's an alert on your phone that says flash flood warning or whatnot, or what to do when you're alerted to severe weather that's impacting your area. So we give community talks throughout the years. We visit schools, libraries. We do a lot of office tours. You can see there on the bottom left. That's an area where we do our balloon release. We have an upper air program where we release a weather balloon twice a day, every day. In the summer, it's 7 a.m., 7 p.m., and in the winter, it's 6 a.m. and 6 p.m. And in fact, if you ever want to visit, this is something you could do. Just let us know ahead of time. You can always email us or give us a call. We can schedule this, and you can participate in our upper air balloon launch program. But we do.
Is that in Newport?
It's out of Newport, North Carolina. Yeah, just south of New Bern, about 20 minutes south of New Bern. This is an example from 2019 or 2018. You guys know the Seafood Festival in the Outer Banks? Sometimes we're able to come up and be there for an education booth. And so this is an example of some of the outreach we do in the community. If you guys were down at the Day of Docks last month, Eric and I were actually there for Day at the Docks and that little outreach booth. It was good to be there. But it's an opportunity to have these one-on-one discussions with the public and the community, especially folks who just moved here and aren't aware of how vulnerable we can be to weather, right? It's quite vulnerable location. So it's an opportunity for us to interact with the public, talk to people about hazardous weather. One thing we started in 2018 were hurricane community forums. This is an example on the left here, so those dates aren't valid anymore. But it's an example. The top one there, we visited Dare County, then Pine Knoll Shores. We had one that was just completely virtual, and then we had one in Jacksonville. So the goal is to communicate what's going on with hurricanes. It's not just the cone map, right? It's not just rainfall. It's not just wind speed. It's also storm surge. It's also the tornado potential. There's so many facets of a landfalling hurricane that you have to be aware of that we spend a lot of time helping educate the public and make sure that the folks are aware. We also sometimes partner with local communities like emergency management. You guys know, you may know the gentleman here on the left, that's Drew Pearson, Dare County Emergency Management, so like the other end of the island from where we are right now. But they have a great emergency operations center. We've been there before. Gives them a chance to talk about Dare County specific issues, whether it's what to do if you need to shelter, evacuation information. You can see there in the screenshot, I think it was 2 years ago, maybe 3 years ago, the state initiated know your zone, evacuation zone. So it's an opportunity to talk about that with the public. We give a brief discussion like we are, a brief talk like we are today, and then we can go into a discussion. We do some that are virtually or hybrid. Obviously, coming out of the pandemic, there were times where we couldn't meet in person with people, so we did a lot of things virtually. We record these, we have them available on our YouTube channel, and sometimes ahead of high impact events, we've used Facebook Live to be able to communicate with the public on that platform. So another way we can talk about weather safety, weather preparedness, weather awareness is incorporating other scientists in our work, in our talk. So this person here is Ms. Sarah Spiegler. She's with North Carolina Sea Grant. She's a fantastic speaker and has expertise in coastal resilience. So we've used her and we've worked with her a couple times to talk about that with the fifth graders. So North Carolina fifth grade is the big year that everybody talks about weather. And so we've used that to talk about, in this example, sea level rise vulnerability.
Any pushback on teaching climate change?
I don't think so recently. I think it's been pretty well accepted. We haven't observed any ourselves. What do you think, Ryan? Have you heard much?
No, and I think like Sarah tells us too, she's also one of the town of Beaufort's commissioners now. And when you see it in your town happening every day, it's easier to believe. So they are working to actively change policies within the town and things like that haven't been touched since the 70s, that they're actually moving forward with now because people are starting to recognize that it's coming, whether you like it or not. So.
Another program we have, it's called Weather Ready Nation Ambassadors. Will be a good example around here. So the emergency management programs would be a Weather Ready Nation ambassador. We have some realty agencies along the Outer Banks that are Weather Ready Nation ambassadors. They essentially serve as a message multiplier, and it's a great way. So sometimes it's just as simple as sharing social media graphics and images to make sure the public is aware of lightning safety, rip current safety, and impending hurricane. So it's a great program in North Carolina, or in our area, just our area, we have over 200 ambassadors. And over 11,000 in the country. So it's a great way to promote weather safety and spread weather awareness and information. It's another way to set up talks like what we're doing today, set up a talk in the community, and we can do that through the Weather Ready Nation Ambassador Program. Another thing that we do that's pretty unique, so when I say we, a lot of times I'm talking about the weather enterprise. What I mean by that is we're the government side, right? We're the ones who are trained to interrogate radar. We issue the tornado warnings, hurricane warnings, flash flood warnings, but that's not where it stops. We have broadcast media. They're absolutely critical, getting on TV or radio and making sure you know down to the roads and the locations, interrupts your TV. Sometimes that's not pleasant, but that's part of their job, right? But they help get the message across. Same thing with emergency management. We're all in one big team together that we call the integrated warning team. So we'll have talks. We usually do anywhere between 3 or 4 meetings a year. We do usually 1 or 2 specifically on rip currents to try to help communicate that. We've done them, let's see, I think we did one this year on winter weather, we haven't done that in a while. And I know you asked about climate change. We haven't really had too many bad winters in a while, right? But it was 2018 or 2017, if you guys remember, it was so cold up here, it froze some of the sound. And actually, I think there's a professor, maybe he's at the Army Corps of Engineers, but it destroyed like $100,000 worth of instruments because it froze and it broke all the instruments. That's what it was, Currituck Sound, thank you. That sounds unimaginable, right? But it can happen, you know. I know we're in an overall generally warming climate, but sometimes we do get these cold bursts. But so we have these discussions about winter weather, tropical weather, whether it's hurricanes, rip currents, severe weather, and we talk about the challenges that we face from our perspective at the government level, from the local level of an emergency manager or a county manager, town manager, and then we also include the broadcast community to help with that. So it's a great way to communicate together and try to help each other solve problems when it comes to communicating impactful weather. During active weather, this is an example here on the left. During active weather, we produce briefings. They're sent out to our partner list. Right now, it's over 500 partners. This is one of the first slides, example from 2019 with Hurricane Dorian. Usually they're anywhere from 2 or 3 slides to 20 to 25 slides. It just depends on how impactful the system is and what's really going on in our area. But it's something we send out first to our emergency management community. They also forward it on to other folks in the community, and then we share it on social media platforms. Right now we're on Facebook, Twitter, and Instagram, and YouTube. Just a couple more slides here. So before I end, I wanted to show you a couple examples from citizen science. So have you guys ever heard of CocoRoss? I know it sounds like a cereal, right? It's not a cereal. So it stands for Community Collaborative Rain, Hail, and Snow Network. But it's a simple, you see the plastic rain gauge, the contrast might be hard to see there, but the top left image is just a plastic 4-inch rain gauge. It will hold up to 11 inches of rainfall. It's quite impressive how much it will hold. But we wanted to talk about it today because of the vulnerable location and where we are in this community. CocoRoss members are incredibly valuable. If you think about what we have for official rainfall information, a lot of it's around airports, right? So you have something in Manio, you have something in Hatteras, and you have all these communities in the middle where we're often missing some of the could be critical information. So if you're interested in it, I think we have a couple of flyers. We can always talk after the presentation if you want to know more about it. But I just wanted to bring that up. The line there at the bottom is really what's interesting to me and important. If you're part of the program and you have to observe during a high impact event, you become part of the official historical archive for that event. So for example, in Florence, we had Anzo County, Eastern Anzo County, Western Carteret County had anywhere between 30 and 34 inches of rain. That's an insane amount of rainfall in about 3.5 days. There were no airport observations of that. That was from the CocoRoss program. That's where the official records came from, a 4-inch plastic rain gauge that is pretty darn cool. So if you're interested in citizen science, this is a great program to be a part of. I've been part of it since, when I was in Maine and New Hampshire. I helped start the program up there. But it's a nationwide initiative. It's also in the Bahamas, Canada. It's really unique. It's really a neat program, citizen science-wise. And then another one that really applies here in the Outer Banks are king tides. Now, we just came out of a king tide cycle, if you guys are aware of it. But there's that NC King Tides, that address there at the top will allow you to go to the website, learn more about it. There's a way to download an app to take photos so that you can be the citizen on the ground showing it how the higher water levels are impacting where you are. So we wanted to show that as an example. I think I'm at the end of my part of the presentation. All right, so I'm gonna hand it over to Ryan.
You left me an extra 3 minutes. That's
Oh, that worked out perfect.
bad news for you guys. All right, so my name's Ryan Ellis. I'm the Science and Operations Officer. You might say, what the heck is that? Well, we had this discussion yesterday. David's the realist, I'm the optimist. So part of my job is dreaming into the future about where we're going. And his job is more day to day. So I get to do a lot of fun dreaming and stuff like that. He deals with budgets and things like that. So, but what we're doing here is we're at an inflection point in how we forecast and the kinds of information we're giving and the kinds of things we're doing with that information. And so we are focusing a lot more on something called impact-based decision support services. And that is basically what David was talking about, where we're helping the emergency managers make decisions. Now, it's decision support. We don't make the decisions. We have a lot of school superintendents that'll call us and ask us if they should cancel school or not. We cannot make that decision for them, but we certainly can customize information for them in a way that they need for their particular decision to make. That helps them out. So it's a lot of building partner relationships. It's a lot of explaining the entire situation about what is going on with the weather. And so with that, we are going towards more probabilistic forecasting. And let me go back here. So probabilistic forecasting versus what we call now deterministic forecasting. So deterministic forecasting is, I just give you a number, that's the forecast, and that's what you go with. So it's gonna be 82 degrees today. More probabilistic forecasting would be something like, there is a 70% chance that it's gonna be 80 degrees today. But you should also know that there's a 10% chance that it could actually get to 90 degrees and you might have some heat issues with some certain people in your community that might be susceptible to that. So it's providing more of the whole story. And so a lot of partners now are getting used to that, and so they want the whole story. It's not just about give me your best guess to the forecast and we're just gonna go with that. They also wanna know, is there a high impact event out there that's possible that might not be as likely to happen, but if it does happen, we're gonna be in a lot of trouble. Think about Western North Carolina right now, right? So that's where we're moving to. And the other thing that we're looking at a lot, and this is an interesting diagram, but there are a lot of parts to the forecast. And what was traditional weather forecasting was we would make a forecast, send the products out, and good luck to everybody else. You know, you make your own decisions, you do what you need to do. But there's a lot more that's going into it now. Now that we get the forecast out and we're forecasting for those impacts, we also are looking at things like socioeconomic modeling. Which communities that we serve are gonna have a harder time with this event than others? How can we brief emergency managers so that they can get more resources to those communities ahead of time as opposed to reacting after the fact, right? So that's going into it now. There's a lot more communication science with social media and all these different things flying at you. How do we know what to trust? How do we know what not to trust, right? So there's a lot of communication science going into it of how can we best influence the community to make the best decision for them. And then in the end, it's a lot about human behavioral psychology. I didn't realize how much I was gonna learn about psychology in this job. When I went to college, it was all textbooks about severe storms and things like that. But if we send a forecast out and somebody doesn't hear it or doesn't act on it, then what good is the forecast? The forecast is only good if you're helping to save those lives. So a lot of different things that we're looking at now. The other thing we're talking about is everybody's talking about AI, right? Artificial intelligence. Won't it take our jobs? And there are a lot of things that AI can help us with that we're using already. For example, David's here, I'm here. We speak English, but we don't speak Spanish, Chinese, French, any of those languages. In the New York City office, they serve people that speak 200 different languages, right? And in an office of 20 people, we can't do that. But we can use AI to take our forecast and translate it into all those languages. Now, we have to do some training of that model. We can't just send it out there, or sometimes it's not translated correctly. So what we actually do is we're taking one language at a time, and people who are native speakers of that language that are in our agency are helping to look at the output that's coming out of the AI and say, nope, you need to correct this, 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 and this. And then the AI actually learns what's correct for that language. So it's interesting. We're using it for things like that. We're using it to sort through tons of data. Sitting down at a desk for 8 hours on a shift, can't possibly go through the amount of data that we have available to us. So the AI gives us a starting point, but it's still up to us as forecasters to say, okay, now that we have that data sorted, where do we think the forecast is going to go off the rails a little bit that we can adjust, and then how can we get that out to the community? So there's a lot of different things that AI can do. But then the other part of it, we talked about developing relationships with people like Drew up the street as the emergency manager. Now, AI is not great at human skills. AI is not great at building trust with another human being, right? So we get to go in and fill that role, which is great because we love interacting with our partners. So here's that probabilistic versus deterministic part of it. Now, you might still be in the camp of, do I want probabilistic data? Do I need that? Do I understand it? Well, it's popping up all over the place. Now, we're in North Carolina. You might have heard recently that sports betting has become something that's happening here. If you watch a sports game now, I was watching the baseball game the other night, they got probabilities all over that thing, right? So people can understand it. I think it's just up to us to educate on how best to use it, right? And so we're actually gonna do a little bit of a demo. And unfortunately, I have to come over here for that. So we'll get off of this for right now. Okay, so this is a system that we're using now. The other thing that's changing is that the more our partners are relying on us to be a partner in helping tell the whole story, they want to be closer and closer to us. And so there are certain times where just being in the office isn't good enough. They want us to come to the emergency management center and be there on site. So this is a tool now that we have. It's internal to us. So you're getting a sneak peek at it here. But we can take this tool to the emergency management office, and I can access it online. So everything is moving to the cloud where we can access it from anywhere. So like our director likes to say, if we want to set up in a Bojangles, we can do it and give the same level of forecast expertise as we can in our local office. So it's allowing us to get out into the community a lot more. So this is the first map that comes up, and you can see I can kind of move all around the country here. I could zoom in on North Carolina here, and this is a temperature map. As I zoom in, I get roads and things like that. But we're doing a lot more with probabilities. So one thing that we can do, we know over the past couple of weeks, how many people have got rain at their house? No hands going up, maybe just a little bit, right? It's very dry out there right now, and it's very dry out west, so we're into some fire weather concerns. So one thing I can do here, if I bring this up, is something called a joint probability. Now I can give you the probability of less than 30% relative humidity, but I can also give you the probability at the same time of wind speeds that are higher than 15. And so this would be of concern for our fire weather folks. And out here, out west, notice we have a few things popping up. And if I use, let's see, where's my, I have to kind of try to go down here, but,
When you say a few things, do you mean fires?
Yeah, yes, there are some fires popping up. These are not fires. I can show you where the fires are, though, because I can put on here. My screen size is a little small, but these are, when it pops up, it will show fire parameters, and there they are. So anything you see in red here is a current active fire. And this is up in Idaho, so you can see all of these things. So we send out, we have meteorologists called IMETs. We have two in our office. They actually are deployed to some of these fires out west, and they actually camp in tents near the fire, and they bring their own instrument pack so they can take observations right there. And they are there on site to help figure out what the fire conditions are gonna be. Now, anywhere you see these little purple splotches, this is where the winds are gonna be higher and the humidity is gonna be low. That's bad for fire, right? And if I can find a way to make this work here. See, there's a...
Live?
This is live right now, yep, live right now. But what I'm trying to do is get rid of this bar here.
You need a young kid to help you, he can do it quickly.
See, there's this thing here. There's another thing down here that I need to access to be able to see it. Yeah, we'll have to maybe not show that part. So anyway, these are areas, though, where you would have, what I was going to show you was that over the next 24 hours, New Mexico is going to have a huge amount of probability for strong winds and low humidity. So those would be areas that our person on staff would say, hey, we got to be careful over the next 24 hours. We have conditions that are ripe for fires, and anything that does form is going to be really bad for those areas. So other ways we can split up the data here. Now, if I have my 2-meter temperatures
Would a
here.
notification go out telling people not to like?
Oh, yes, yeah. And in some cases, if the winds are strong enough, there'll be what's called a red flag warning, and that tells people not to burn and things like that. So in addition to showing temperatures, we also have winds and all kinds of other things. So here would be the winds currently over eastern North Carolina. Now, this is model-based. It is not exactly observations. This is what the forecast models are predicting, but in the short term, it's almost as good as an observation. And so you can see not only the direction and speed that the winds are going, but we can present it in different ways. So this one looks a little bit cooler to me than the other one. So we have that. But what we can also do now is, if we're looking at data probabilistically, we can show for one particular site, and I'm going to use Manio. So I can put Manio in here, and I can get No, these are not AI generated. These are our forecast models. So like when they say the models are showing that the forecast is going to do this, these are physics-based models. So there are some AI models that are out there. They're not good enough yet to get the quality of data that we're getting here, right? So I can show things on a time series. I can show, these are all different models here that we can look at that are showing different forecasts. The other way that I can do it is I can show it like this. So this is what each model is saying the temperature is going to be. And so if we change this to rain, let's do something like
Is
this.
all this information like beamed to you through satellite?
No, this is all supercomputer based. So the model is basically a bunch of math equations that are run, and then they tell you the forecast out 7 days or 10 days or how often it goes, and then they are piped back in through what's called the cloud. So that's how data is getting back into the system itself. Unfortunately, it's showing here that we are not going to have any rain in the foreseeable future. So that's 24-hour precipitation right there. But if I look now at, let's say,
So do you have special equipment that's feeding this data that you do the mathematical equations for?
yes, so all the observations at, say, all of the airports, the weather balloons that David talked about, satellites that you mentioned, radar in some cases, they're all of that data that's current and real is going into the forecast model, and that's the starting point. It says, okay, here's the forecast, here's what's happening right now, and if we want to make a forecast, we are going to have to know what's happening right now, right? And so the better that our data is going into the model, the better the forecast will be coming out. And that is why, if you look at a 7-day forecast, it is going to be not quite as accurate as a 5-day forecast, not quite as accurate as a 3-day forecast. The closer you are to the current time, the better the forecast usually is, because you have the best data at the current time, right?
When you say airports, does that include little airports? Or
Yeah, most airports, Little airports to a point. If it's like a grass strip or something in the middle of nowhere, sometimes they don't have a system. But if they do have an observation system there, it will get into the models, yes.
Who makes those
Who makes the,
observation systems?
a lot of, there are different companies that make them. It depends on what system that they have. But they are maintained either by us or the Federal Aviation Administration. Those are the two that would do that. So there's a lot of different things that we can look at on here. I am going to go back to the main map. We got about 5 minutes left. Oh, the other thing we can do is, back to the main map here. I'm just gonna reset, because one thing we can do is make these graphics. And what's awesome about this is that we can put in on the fly, you know, kind of the graphics we want to make. So return to the chart. Maybe we put a temperature in. And so it will give us different types of things that we can put on these charts. So whatever I want it to put in here, it will do it, and then I can update the chart, and then these can go right to social media. So the nice thing about this is as close as we have right now to something that the broadcasters have, where they can pull up anything in the forecast and put it into a graphic, and it's immediately on your TV screen, right? We can do the same thing for that with some of these, and then send them straight to social media, things like that. The other thing we have is, now this looks crazy, but this is how kind of some of the balloon data looks when it comes back. And so this is called a skew T chart, and it's actually doing that for some of the model data that we have. So what you're looking at here is the red lines are temperature, and this is height, and this is the temperature down here. So if the line moves this way, it's warmer. If the line moves this way, it's colder. And then this is the dew point here. And so anywhere you see these lines further apart, like here, that's drier air. And anywhere you see them close together, that's more wet air or moist air. So we can get an idea of how high clouds might be based on how close together they are. So if there were gonna be clouds in this situation, they'd be at this height right here. So we can, that's really useful in the winter time, right? Because in the winter time, we can look at the temperatures and say, okay, where, if we have moisture, is it gonna be below freezing? Is there a warmer layer of the atmosphere where as that ice falls through, it's going to melt and then maybe be just rain by the time it gets here? Or if when it hits the ground, is it gonna be less than 32 degrees where it freezes on contact, right? So this type of a plot is extremely important for winter weather forecasting. But this is what the data would look like from a balloon when it comes back to us. And so we can do that at any place. That's about it. We're wrapping up. We've got 2 minutes here, but I'll start taking questions if anybody has questions about some of the stuff we had. Yeah?
Recently, there's been some talk about adjusting the categorization of hurricanes. Perhaps introducing a level 6, or as some would argue, well, you know, it shouldn't just be based on wind speed, because so many other factors contribute to the damage. Duration of the storm, how wide the wind field is, the amount of precipitation, all of these different things. And maybe there's some type of composite way of categorizing hurricanes that might be more beneficial than what we've got presently.
Yeah.
So I'm just wondering if that's something that's ongoing.
Yeah, and if Eric was here, he would tell you right away that it's the water that kills, not the wind, right? It's the water all the time when we look at statistics like that. So to have a category system that's only based on wind is not incredibly beneficial. So while it would be good to do that, I don't think you'll see it for some time, just because there are so many factors at play. The Hurricane Center has to categorize things based that way, based on international meteorology law. So there are different ways, there are a lot of hoops to jump through to change it. But what we are doing locally is that we are trying to take as much focus away from the category as possible. And we will, so if you look at our briefings, if you look at our social media posts, we want to go to that impact-based system. What are the winds, what are the impacts, and which locations are going to be impacted by winds? But also, here's the inland flooding that you can expect. Here's the storm surge that you can expect. Here's where the tornadoes might be most likely. And getting to that, like, wherever you are, your experience with hurricanes is going to be different, right? You might have a house that's right on the sound and you're worried about storm surge. You might be living in Greenville, you don't care about storm surge at all, you care about inland flooding, right? So depending on where you are, your experience is going to be different. Do you have anything to add there?
That was well said.
Yeah, I'm curious about what happened in Asheville. Like, what was your probability of all of that rain and what happened with them? And I'm sure there has been a lot of analysis since then.
Mm-hmm.
So what could have been done differently, or could there have been anything done differently to prepare the citizens there?
Yeah, I'm not sure, and we don't forecast for that side of the state, so specifically, but you know, what I can tell you is that what we are seeing now is that was an extreme event, like off the scale from what we've seen. What we are getting better at, and what the models are getting better at, is knowing when that we have a lot of moisture coming up ahead of the storm, like we did in that situation. So it rained 7, 8, 9 inches in some places before the hurricane even got there. We're getting better with messaging those kinds of things. I think the issue becomes in the mountains, it's just the terrain is really hard to, once that water comes down, it's going to flow into all those nooks and crannies. And we are getting better at hydrological modeling, which is where we're modeling how the water is going to flow once it hits the ground. And as those models continue to improve over time, and AI will help with things like that, maybe we can get better policies for insurance. We can get locations that are more likely to see something like that than others. And then it's a matter of building codes and things like that. And so there's so many moving parts with that, though. It's a great question.
I have noticed that weather forecasters seem like they are talking less about humidity and more about dew point now, and I don't think I understand dew point. Could you talk a little bit about the distinction between those two and why dew point seems to be?
Yeah, so dew point is simply a measure of the moisture in the atmosphere, right? And so, but it's an absolute.
So on the map here, or on the graph, that's the dew point.
Yep. So
that
it's an actual temperature per se, but it's measuring the moisture. So humidity is just a percentage of how much moisture is in. So if these two lines touch, your dew point and temperature, you're going to have 100% humidity, right? Because the air is completely saturated. You can't get any more water in there without it raining out. If your lines are further apart, like they're down here, your relative humidity is going to drop. Now, the difference is the dew point is an absolute number. So if I say the dew point is going to be 30, that's really dry compared to the 70 degrees that we had out there today. So that's a big spread. right? But the relative humidity part is just a 0 to 100%, right? So it's how much of the atmosphere, how much of the capacity of the atmosphere to hold water is taken up. Does that make sense?
Is that what the definition of dew point is? Because I really don't know what it is.
Definition of dew point? Do you have a?
It's the temperature at which a molecule brought down to saturation. I don't remember the technical term, but it has to do with measuring moisture in the air.
Of the air. So like,
Yeah.
So
yeah.
It's raining.
Right, so, well, no, that's humidity. When it's 100, it's raining.
Yeah.
Dew point is, okay, if you want to saturate the air and you're at 70 degrees air temperature and you're at 30 degrees dew point, the temperature would have to go down to 30 degrees before it's saturated.
Okay, so it's a
Yep.
ratio,
Yes, it's a ratio.
which constantly changes.
Yes.
What's the,
Yeah. I think you're
what's
okay.
the most difficult or interesting challenge of coming up with an accurate forecast?
The most difficult challenge is the fact that if we wanted a perfect forecast, right? If we wanted a perfect forecast for the entire globe, we would need to know the exact parameters of what it is now everywhere. So I would need to know the temperature here and here and here and here and how it's changing. So the biggest challenge is we don't have enough observations. There's huge holes between observations. And then as you go up in the atmosphere, well, we've got all the airport data, right? Satellites can help fill some of that, but there are gaps in the observational data. And every time you have a gap, you're guessing at what's in between those gaps. And when you guess at what's in between those gaps, your model will fail.
Okay, what can be done to fill some of those gaps?
More observations? Yeah.
You're kind of seeing it in this graphic here. So the key word up there is ensemble, meaning that we're using multiple models. They'll have a little bit different parameterizations or their math and physics that create that model. But when we look at the full suite of all the models, we can generally get a really good handle on what the likelihood of something's going to be, whether it's chance of rainfall, high temperature, low temperature. So the ensemble approach really is what helps us fill in some of those gaps.
So to explain that a little bit more, how many people have heard of the European model, right? That's just one. The Hurricane Center is looking at now close to 1,000 models, right? And what they're doing is when you look at more and more data, that data is going to give you more confidence in certain places. And so we're filling the gaps that we have with observations by using a statistical approach to fill that. That's getting better and better and better.
Well, thank you guys for coming, making the trip. We appreciate it. Really nice talk. I'm hoping you can another definition or clarify a term that seems to me has kind of come into our society in the last decade. I hadn't heard it before that. You used it in your talk, a king tide, right? So technically, what is that? So if you have a spring tide, is that all the other forcing mechanisms like wave run up and wind forcing and whatever else can give you flooding? Or what does king tide mean? And is it actually forced by gravity like the tides, or what is that?
Do you have that one?
I'm going to try my best on this one. Let's see, because I'm not an oceanographer and I'm not an expert on this one. But it's essentially the highest tides that occur, usually, 3 to 4 times a year? But it's not counting wave run up or any other parameter. It's really just purely astronomical, but it's the highest of the astronomical tides just a few times a year. That's my understanding.
There's certain times in the Earth's orbit that it's going to be closer and there's going to be more gravitational pull. Those are the times that we see it. But yeah, it's strictly astronomical. So all the other stuff you talked about, wave run up and things like that, that's on top of that. So where it gets challenging for us is we're always looking at the calendar and seeing where the king tide is and crossing our fingers that we don't have a coastal storm at the same time, because that's when you're going to compound all those effects of the wind on the water as well as the astronomical tide. Yeah.
So
It's on. Yeah.
I was in a restaurant in Raleigh, I think last summer, and there was a tornado watch or something came through, and I swear my phone was the only one that did not go off. Everybody else in the restaurant, their phone went off. Am I missing something? Is there a location finder based for alerts to go off, or?
So your phone has what's called wireless emergency alerts. You may have accidentally turned it off.
Oh.
So I would check the settings on your phone. Sometimes this is what happens. There's Amber Alerts, and people get frustrated for something that's the other end of the state. And they'll say, mute this or turn this off. And then you won't get a flash flood warning or tornado warning, a storm surge warning. Those kind of things won't come through on your phone unless you turn it back on. So I would just check the alerts on your phone.
The other thing that can happen, though, if everybody around you has Verizon and you have AT&T or something like that, the carriers have their towers sometimes in different locations, and sometimes they don't quite line up. I've had that happen to me where I was driving through an area that had a tornado warning, and somebody else in the car with me, their phone went off and mine didn't, or it goes off at a different time, like it's slightly later based on how far away you are from the cell tower or things like that. So, but what's happening is we're putting out a polygon, a box where that warning is, and depending on where you are on your GPS on your phone, it's supposed to go through the nearest cell tower and then alert your phone. So it could be a company-based thing. Yeah.
Two questions. No, I've forgotten what it was. Give me a second. I swear I've forgotten. If I remember before I'll ask you.
You can talk to us after, too.
Yeah.
A friend of mine knew I was coming to the seminar, and he asked me to ask this question. And what his question was, is there any ongoing research in terms of controlling weather?
Not that I'm aware of.
No, there were things many decades ago, like one you can Google when you get home, it's called Project Storm Fury, where they tried to figure out a way to tear apart hurricanes using silver iodide. It didn't work. But that was 40s and 50s, something like that. But there's nothing.
There was a lot of attempts in that time frame, that 40s, 50s, even into the 60s. And some countries have tried it. There's no solid evidence that cloud seeding actually works. Yeah, and so basically the concept there is that when you have a water droplet that needs to condense and form a cloud, it needs something to start with, a nucleus. And usually that could be like a dust particle or something like that. So the thought was if you put more of those starter particles in the air, there'd be more things for them to grab onto and then form a drop and then eventually rain out. Not a lot of evidence that that actually works.
To get back to rip currents, you had a chart there where you said something about friends helping you with the rip currents. You have a bunch around here who are doing it. A number of us in the mornings catch sunrises. This morning I'm walking, there are 8 people from Albuquerque, New Mexico. So I asked the question, do you know what a rip current is? And they say, sure. I said, okay, tell me. And then we got into education. And then I said, do you see one? They said, where? I said, right there in front of you. And then the last thing was, they had little kids who weren't with them. I said, you know, you can make a rip current with the little kids. Go build your sandcastle. The moat you have in front, when there's too much water in it, it breaks through and runs out. Where it breaks through, that's our sandbars, and that's a rip current. And the people's eyes went, oh, okay. And then the last thing is, like we always tell everybody, you go in the water, have a boogie board with you for 2 reasons. Number 1, you look cool. And number 2, it's the cheapest life preserver you'll ever have. Yeah.
Yeah, that's awesome. And
Well said.
there are so many different entities that are helping with that. Certainly up here in Dare County, Also down where we are, the town of Emerald Isle has now, they've invested in TVs. I go into Publix now and I'm at the checkout and I see a TV that's circulating rip current information 24/7. That's the only thing that TV does. I go to the local pizza place where I get my pizza every Friday night. They've got one too. Now we also have, we know we have a lot of vacation home rentals and things like that. Some of the real estate companies might put a rip current flyer on the table so that when that family does come from New Mexico, they see it on day one that they're here. And that's really what we need you to keep doing, because the word of mouth education is the best way.
It's saving lives.
Yes.
Take one more.
You mentioned that, obviously if it's a 2-day forecast, it's much more accurate than a 5-day or a 10-day.
Yes.
So what does that curve actually look like? If I'm looking at a 10-day forecast, should I just take that 10th day with a giant grain of salt?
In some cases, however, if you were this last 10-day period, it's been pretty nice the whole time. So there are periods of time where the confidence in the forecast is pretty good. And you could say, okay, the 10 days probably going to be about the same as it is today. But a lot of times, you're exactly right, that 10-day forecast, it's going to give you an idea. It's not worthless. You're going to have a starting point, but the key message there is you got to keep checking up on it, because it's probably going to change. And when you do, you can start to see trends. So for example, maybe if you were looking at a hurricane 10 days out, and it said it was going to hit here in North Carolina right at the Outer Banks. And then the next day you come back and you see that that track has moved a little bit to the north. And then the next day a little bit to the north. You can kind of see that trend forming that you can kind of get a little bit more confidence in your forecast. So it just depends on how certain the forecast is for that time period. But in general, if somebody's telling you that I've got a 45-day forecast for you and you're a bride planning your wedding on that day, I wouldn't count on it too much. So,
Brian, David, thank you very much. We appreciate it.
Thank you.
Feel free to grab any of those on your way out. We've also got some information for our programs here at CSI, and if you want to leave your email for getting on our mailing list, please do. Thank you all for coming.
Thank you. Last good rip current story. 2 years